to jump right into the laws of logarithms, much like we did the laws of exponents earlier this chapter. And just like with exponents, we do have logarithm police that if you do break these laws, they will find you. Laws of logarithms. All right. So we got not quite as many laws as we had with exponents, so it's kind of nice. But we will jump right into them, and if you have a situation where you have a log of base b and m times n is your argument, so log mn base b, that can be separated into two separate logs through addition. Okay, and these are just properties or laws. We are not going to go through the proofs. You'll just need to trust me on these. We have the log base b of m divided by n. You can probably guess that that will be changed into subtraction between two logs. If I have two individual logs that share the same base, then the arguments in those logs must be true. This is key the whole way through, that the bases remain the same. Okay, very, very, very important. And we have log base b of m to the p. So in this case, the argument, the m, is being raised to the p and not the entire thing. All right, that is equal to p times the log base b of m. And again, take note of the base. Now this one is an interesting law, and I'm going to kind of verbally explain it to you without writing this down. So think about what an exponent is. Exponent means we redo something over and over and over again. So this is a certain number of m's. So log base b of m times m times m times m times m, right? So something becomes a multiplication problem with a bunch of m's. Well, multiplication splits up into addition. So if I have log m plus log m plus log m plus log m, I have p number of log m's. So that's how this jumps to the front magically. I think that's important to know, that it's not just magic where exponents come down to the front. There is some reasoning behind that. And much like in the last video, this is the important part of this one, so we're going to put a nice little box around this for you. Make sure you know them, and make sure you know them well. It looks like I lost an equal sign here, so let me throw that back in. And an equal sign there disappeared. You know what? A lot of stuff disappeared, so let me go forward and backward, and we got an extra thick equal sign here. Everything's back. All right, so let's work on a couple examples with these laws of logarithms. And there's really two examples. We want to expand and condense. So let's do one side with expanding and one side with condensing logarithms. So let's say we want to condense. We'll start with condensing, where we have log base 2 of x plus log base 2 of x minus 2 equals 3. Well, the key here is to recognize I have the same base. I'm adding them. So if I look at my first property where I'm adding them, that's the same as multiplying them. So I can say this is log base 2 of x times x minus 2 equals 3. So a little more algebra. That becomes x squared minus 2x. And now by using the definition of a log, remember, log x base b equals y if and only if b to the y equals x. So this statement right here is the same as saying 2 cubed equals x squared minus 2x. 0 equals x squared minus 2x minus 8. 0 equals x minus 4, x plus 2. So x equals negative 2 and positive 4. And we've used exponents to solve a logarithm. Imagine that. So let's do some expanding perhaps. Let's say we have log base b of mn squared. Well, that's going to be the same as log base b of m plus log base b of n squared, and that will be the same as log base b of m plus 2 times log base b of n, right? My power jumped to the front. Okay, and that is an example of expanding and an example of condensing logarithms. Let's take one with a few more numbers in it. Let's say you're asked to simplify. This will be our last example for today. Simplify log 45 minus 2 log 3. So you have to recall our properties do go back and forth, left to right or right to left. So I see a number in front. I know that can go to the power, so I'm going to put it to the power and make that log of 3 squared. Well, log of 3 squared is the same as log of 9. And now I see subtraction. I know that came from division. So I can do log, remember this is base 10, of 5. And if we want to take that and give ourselves an approximate answer, we can say, hey, I remember that 10 to some number equals 5. So I can approximate that y must be between, well, 10 to the 0 is 1, and 10 to the first is 10. So my answer is somewhere between 0 and 1. And that's something we can use for another day when we talk about realisticness of an answer. The bottom line here was that we condensed our log into a single logarithm. And notice I wrote for emphasis only. This base of 10, we do not need to recognize bases of 10, the common logarithm, by writing a 10 in there. Okay, I did that just for emphasis since I knew I was going to be doing this approximation here. Hope you enjoyed the laws of logarithms, and watch your backs. The logarithm police are watching. Have a nice day.